The
Wow.
incredible edible Bob Ingram.
Yes. He is going to be on the After Action Report. The next episode is going to be August 14th, 2024 at 19:30 hours Eastern Standard Time. Once again, free for all. Facebook, YouTube, comments are on. Bring it.
Come in, break his chops, and if you can't catch it live, it will be archived on YouTube, until they shut down YouTube.
Yes. So that's going to be happening. I'm kind of looking forward to that one. I got to get some pictures from him. Yeah,
I am. I get excited for that one. The McCardle one was exciting too, because these are guys that we, there's a different level of excitement for guys that we know, and then the guys that we're learning about, like for the first, guys that we're having on that we really, have dealt with on a professional level, but not on a personal level. So Bob Ingram is a fun one. Our Battery Destroyers Club, episode 3 is in the works. We will be doing all the filming by the end of August, beginning of September, and hopefully we should have some Teslas to burn. We'll give you information as to when that show is going to air.
Yep, and lots of new hazmat guys and HMAF.
That's right.
Swag.
If you want what Bob's wearing, go to the store and buy it, because it's they are, I don't know how popular hotcakes are, but hotcakes are selling like these shirts. Let's just put it that way.
This is the Methyl Ethyl Death shirt, and it is very popular. That's OG. We have some continuing challenges. It's going to be September 3rd, the 6th, the Dangerous Goods Symposium, which is Label Masters. We're going to be keynoting that one September 3rd through the 6th. Virginia Hazmat, September 10th through the 13th. Hot Zone, CBRNE Convergence, and as well, doing some pretty good ones there.
Yeah,
I like that.
Cool.
That's
And
good.
we'll be doing something different at CBRN Convergence. We'll just leave it at that. We'll be doing something different.
I am looking forward to this episode.
Yeah. All right. So let's set the foundation for this episode, because it's important. Let's be real. 75% of the time, hazmat is I'm not going to say cut and dry, but you get a certain technique going, you get a certain thought process, you're running the same chemicals over and over. It isn't until something weird happens that you have to start to think outside the box, and you have to really learn about a chemical. So we were like, well, let's start really taking a deep dive into the chemical. Let's start understanding how it's used, where it's used, what are the ins and outs of everything about the chemical. So we're going to do helium.
Yeah. And you know what? This is one of those weird ones. I say like in class, and they're like, I dare somebody to find a compound with helium in it. It is the most unimpressive, gas that's out there, and is so crazy. I don't want to say it's a crazy abundant, because you would think, I can just pick up a tank of this stuff at the local party store and get to work with this thing. But it is, as you'll find out, quite the commodity.
It is. It has a really complex history and current history unfolding to it, which really, listen, like from a hazmat point of view, we understand simple like we get all that, but let's like learn more about the chemical itself.
All right, so let's go into the chemical and physical properties. First off, is that it is pretty simple, because it only has 2 protons and 2 neutrons and 2 electrons. Now, that's a key component of the thing, because if I just said has 2 protons and 2 neutrons, end of sentence, that would be called an alpha particle.
Right. Which, is kind of a little hint where helium regenerates itself from.
Yeah. So, now its atomic mass is approximately 4 atomic mass units, or AMUs.
Now, if you didn't get my joke from the beginning of our ad, it is a noble gas, meaning that it is chemically inert. And that's because those 2 electrons that hydrogen has, it has them in its outer shell. It has completed its valence electrons, because that initial orbital is 2. It makes helium non-reactive with any other element or compound.
Yeah, it's a weirdo, which is why I like it. And it has a state of matter, right? At STP, standard temperature and pressure, which everybody knows is 68 degrees Fahrenheit. At sea level, helium is colorless, odorless, tasteless gas, but it makes you talk funny, and it remains a gas down to extremely low temperatures.
Yeah, it has a boiling point and a melting point, just like all other elements, but they're really, really low. Like it boils at minus 268 degrees centigrade, which is around 452 degrees Fahrenheit. Freaking cold. And if you throw just a few more degrees onto that, it's going to solidify. But first, you have to put it under a lot of pressure. So you put it under a lot of pressure, then you make it super cold, and at minus 457.96 degrees Fahrenheit, you kind of get a solid-ish substance.
Right. So that's a weird part of this thing. You would think, because everybody thinks in relative to water, right? Where if I just
make it
chill
cold.
this thing out,
Right.
Just chill it out. I don't think about the reference of pressure. But this thing, with only a couple of more degrees of a shift, add in a ton of pressure, I make ice. Without the pressure, you don't make ice.
Right.
Helium ice.
Right. It's kind of similar. It's kind of similar to the degree that CO2 can't exist as a liquid at our atmospheric temperatures. It has to be placed under pressure. The solid doesn't exist without pressure for helium.
Interesting. So we have a density. Helium is much less dense than air, which is why it's such a party favorite. And it's about a seventh of the density of air at STP.
A seventh. It's so tiny. All right, so
the kids say it's hella up.
It's hella up.
I don't know what that even means.
It has high rise riz.
Oh,
yes. I'm gonna tell it to my kids and they're gonna cringe. I love it. All right. Where do we get it from? How abundant is this chemical? Well, if you're going to look out into the cosmos, helium is the second most abundant element in the universe, making up 24% of the elemental mass of everything that we see. It's found in stars, giant gas planets that should be stars, and it plays a crucial role in nuclear fusion process within these stars.
right. It's also abundant in the Earth's crust. Right? Not to cut the coronas off, but the helium is rare on the Earth's surface, and it's primarily found in natural gas deposits. So it is produced through the radioactive decay of helium elements such as uranium and thorium.
Through that alpha particle that you mentioned before. See how it's all connected, people? All right. It has some really cool characteristics to it. Some things that, that happen on a quantum level. And, make no mistake about it. Nobody understands quantum mechanics. They just learn about it. So one of the cool characteristics of helium is it is a superfluid. Helium-4, which is a common isotope of helium, exhibits what's known as superfluid characteristics when it's cooled to temperatures near absolute zero. Superfluidity. It means it flows without any friction. And it also demonstrates unusual properties like the ability to climb walls of containers.
Interesting.
That's so messed up.
But, I'm looking at the next line, and it's almost an oxymoron where it says that helium is non-toxic, right? And I cannot tell you how many times I've seen this as a fan favorite for chemical suicides, where they put the helium cylinder in the car with them and they put the hose up under their hazmat guy's HMAF branded exit bag,
right?
Which is in the store if you want to pick one up for the kids. But it says it's non-toxic, and yet we use it in chemical asphyxiants. It's almost like the definition of non-toxic is flexible.
Well, it is to a lot of degree, because what they're saying is this chemical itself doing some kind of harm to the body?
Yeah,
like
that's exactly.
It has to be the chemical itself, not that the chemical pushes oxygen out of the way.
No, it's how you categorize it. So helium is non-toxic, it is non-flammable, that is absolutely true, and non-reactive, and that is why it is such a freaking weirdo. It is great for many applications. However, inhaling helium can displace oxygen and pose an asphyxiation risk and make your voice very funny.
Yes, yes. Which amazes me that more people don't pass out trying to make their voice squeaky.
I wonder if before you die, you're like, ha, 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 and then you're like dead.
It's help me. That's awful. That's so bad. I wish I was sorry for that.
Cut that out. You need to be editing guy.
All right. Helium comes in a couple of different types of flavors. There's a few isotopes that are relatively common. The first is going to be helium-4, which is the most common isotope and actually makes up about 99.99% of all naturally occurring helium that is literally floating around.
Yeah, and now helium-3 is a little bit more of a rare isotope with applications in cryogenics and potential future use in nuclear fusion research, which is new wave crap, right? Helium-3 is found in trace amounts on the Earth. Yeah, and now more abundant on the moon's surface. That's
kind of cool. All right. Helium is a gas that is colorless, odorless, and just like me, tasteless. It is the second lightest element and is obviously non-reactive, commonly found in so many aspects of our life that we take for granted. And a lot of those things that we take for granted are going to be in electronics.
Yeah, and now the sources is what interests me about this whole thing, because I was kind of shocked that it comes out of natural gas fields, right? Rich helium reserves are found in varying concentrations in natural gas fields. The highest concentrations are typically found in specific regions with unique geological conditions.
Helium is separated from natural gas. Wow, I can't even do it right when I'm breaking my own chops. Helium is separated from natural gas through a process that involves cryogenic distillation, where the gas is cooled to a very low temperature to separate these different components. This process is costly and requires a pretty significant amount of infrastructure.
Which I know we're going to come to it, but that's one of the reasons why it's such a scarcity.
Yeah, we actually are in a shortage of helium, and these are the reasons why.
Yeah, which is now funny because would you believe that the United States has a federal helium reserve? Yeah, and now located in Amarillo, Texas, the Federal Helium Reserve has been a significant source of helium, and this reserve was established in 1920s and has historically been a major supplier through its role of diminished as reserves have been drawing down. Yeah, and now we need helium, and there's only so much.
Yeah, well, within the United States, we have a lot of natural gas fields. So there is a significant amount of production in the U.S. and, whatever doesn't get used goes back into the reserves. But this is where the helium concentrations can be economically extracted. So we can get it through the distillation, that's expensive, or through the natural gas fields, which is a lot cheaper.
Now, you notice where I said the reserve is in Texas, which is where we pull a good majority of our oil from. But another place is Qatar, right? They have their North Field is one of the largest natural gas fields in the world and is a major source of helium. The country has developed significant infrastructure to extract and export this helium, making it one of the leading global suppliers.
Algeria plays a role, too, in a field that I'm not even going to attempt to pronounce. It is a major source of helium, and this country has invested quite a bit of infrastructure to be able to extract and process the helium from this giant field.
And this is the last one on our list, and the list is, I trust me, it's exhaustive. But Russia has a lot of it. They have the Amur gas processing plant, and they're emerging as a significant helium producer with the development of this plant in the Far East, which is it's expected to be one of the largest helium production facilities in the world.
Now, secondary sources, all right, obviously any type of a liquefied natural gas plant is going to be able to produce helium as a byproduct. Why is that obvious? Well, because in order to liquefy it, you're doing chilling stuff. So as long as you're chilling, you're separating the helium out anyway. That helium can be separated, captured, and transported as need be.
Now, another shocker for me is that you can recycle helium. I didn't even know that was a thing.
I guess you could, right? Because nothing happens to it, even in all the processes that it gets used for. It goes in as helium, it comes out as helium.
Because it's so non-reactive. So given that high cost and the scarcity of helium, recycling has become an important secondary source, which involves capturing and repurifying those heliums like they're like plurals.
In
Helii.
Oh,
Oh, we got some Helii running around me. And in various industrial processes, particularly in industries like MRI machines maintenance and scientific research.
yeah, but we're always looking, not me and Bob, not we as in us, we as in like humanity. We're always looking for new sources. So some of the new sources are like I said we again, somebody else is going to be doing exploration for new helium-rich natural resource gases. And advancements in technology and geology can lead to the discovery of resources that we haven't found yet.
And we even have some non-conventional sources, if you would, that we're doing some, not we, again, I'm not doing shit.
The only thing I'm doing with helium is making my voice sound funny. That's pretty much all I do with helium.
But those people are doing some research.
What do you mean those people?
I don't know. Alternate methods of helium production, such as extracting helium from the air or mining it from the lunar surfaces. And though these methods are not currently economically viable on a large scale currently.
So it seems like there's quite a bit of supply out there. I mean, we mentioned multiple companies have it, multiple fields have it. Why is there this shortage? And believe it or not, with all the supply that's out there, we still have very much a limited supply because as of yet, helium is not actually a viable, renewable resource. And we can't artificially produce it in any kind of large commercial quantities. So the helium reserves are actually very finite, and we use it for so much stuff in our scientific life and our commercial life that it's being depleted really rapidly.
Right. If you think back in the 20s, not that we were there for that, but think back, there was a reason why there was such a reserve, because you didn't have things like MRI machines or semiconductors or scientific research that required tons of this stuff. So that's why there was such reserves, and now that reserve had to be transferred back out into the world and actually in use.
Geopolitical factors play a role in this too. If you just go through kind of those four countries that have the big reserves, United States, Qatar, Algeria, or just those three. I can't remember what the fourth is.
And Russia.
Russia. Right, Russia. Those four, they don't always play nicely in the sandbox. So if the production and the supply are concentrated in these few countries, that can cause a real issue with the supply chain.
Yeah, helium is primarily extracted as a byproduct of natural gas production, right? So it's kind of like the nice thing that comes out the side. But there's other major sources that are geographically concentrated in those countries, the U.S., Qatar, Algeria, right? So if I don't like to play with you, I don't give it to you. And then you don't have MRIs, or you don't have semiconductors, or you don't have those types of things. That could be an issue.
Right. And then, you have these countries, they all have their own export restrictions and trade policies. So as long as everybody knows it's finite, they're going to want to hold on to them. Countries with significant helium reserves, that's exactly what they do. They impose export restrictions, or they prioritize their own domestic needs. Makes sense. I'd hold on to shit too if it was valuable. And the United States has historically had policies affecting the sale and export of helium from its own federal reserves.
Which brings us to trade disputes and tariffs that can disrupt that whole supply chain. For example, tensions between the U.S. and China, or between Qatar and its neighbors, can lead to those service supply interruptions. And if you have a commodity, it's, supply and demand.
Supply and demand.
Babies go up.
Yes, they do. Which then brings us to infrastructure and investment, right? Helium extraction and liquefaction, it really requires significant infrastructure investment. So you have to have these facilities. You have to have the transportation for it. You have to have the ability to capture it in the field. And countries often lack the necessary infrastructures to be able to do these things. They face the challenges of scaling productions, and that, of course, affects the global supply chain.
Which now, okay, we've established we need helium, right? For our processes, for our science. So we now need to think about investing. And so the stability of the geopolitical politics, it comes down to politics. It influences the investment. Does the government put it into this pot or that pot? And so unstable regions may see reduced investment in those new helium production facilities, impacting long-term supply and thus advancement.
And like anything else, right? Those unstable regions then produce regional conflicts, which only increases the instability, increasing the difficulties for those countries to be able to produce the helium. Perfect example of that is the tensions between the Middle East or between Russia and Ukraine. Like they affect so many other things, they can affect the helium that's coming out of these areas.
Which enters sanctions, right? So we can impose sanctions on helium-producing countries such as like Russia or Iran, whatever it is. That can limit their ability to export that helium and affect, again, the global supply.
Now, if a lot of helium comes from natural gas production or the pulling out of natural gas from the earth, you can imagine that environmental regulations that impact oil and energy are also going to impact the ability to extract the helium in its natural state. So compliance with regulations can significantly increase costs.
Right. And then you have your policies, which again, politicians enter stage left, is that you have these global climate policies, and the transition to renewable energy sources can influence the natural gas production, thus impacting the helium availability. So as we pull less natural gas and oil out of the ground, we have less helium. It's kind of like one of these things.
Yeah, it goes up as it goes down. And, you turn around and you go, okay, but what about all these strategic reserves, right? The U.S. Federal Helium Reserve has played a significant role in the global market. And it, depending on, right, just like everything else, depending on the politician that's in, the Democrats, the Republicans, the whatever, all of that plays a role in selling off or holding on to, which would deplete if we sell it off, that's going to deplete our reserves. If we hold on to it, that's going to increase the shortage, and it all changes the future supply stability.
Right, which now we've been talking about the government, but what if you have an industry, right? You're in a major industry relying on helium, such as like medical imaging or semiconductors or whatever. Your company may stockpile helium to hedge against that supply disruption. So now there's little mini banks popping up and the global market is not there. And that might influence the market dynamics and prices.
Right. And going from the small to the large, right? The people that hold on to these large reserves, it's almost like a monopoly. So if one little thing happens to the people holding on to these huge reserves, it can have significant changes to the market, and these can lead to increased prices, not stable prices, and availability through the production decisions.
We're going to finish it up here on this one with volatility.
Okay.
And we'll come back to it a little bit more, but you can imagine with all this thing being said, with those events, the supply disruptions and changing demand, that can lead to significant price volatility where it's shifting. Now we're talking about not about hazmat volatility, we're talking about price volatility, which means it goes up and down quick. So industries dependent on what helium must navigate these fluctuations, which can impact operational costs.